Hello, good day, and welcome to today's class. I'll be continuing algebra, and today we're looking at linear equations, inequalities, and graphing. Linear equations, inequalities, and graphing. Now, we start with linear equations in one variable. In the last class, when I looked at introduction to algebra, I gave some terminology, some basic terminologies that are very important in algebra. I talked about variables, and I gave it as a basic terminology and something that will occur a lot when we talk of algebra. Now, a linear equation is an equation where the highest exponent of a variable is 1. When I talked about variable, I said they are kind of letters that represent numbers. For instance, we majorly use x and y, and then I said we could use v, t, a, u, we could use p, and so on and so forth. They represent numbers in algebra. Okay, so when the variable has the exponent 1, what that means is, for instance, x is to the power of 1. That's the same thing as just x. I also defined an equation as an expression with the equal to sign. So for instance, 2x plus 3 is an algebraic expression, but when it's equals to 7, as we see here, it's an algebraic equation. Okay, x here is to the power of 1, and that's why this is called a linear equation. In another class, we might be dealing with quadratic equation and quartic equation and other types of equations. So this is an example of a linear equation, and they are called linear because if you draw them in a graph, it's going to give you a straight line. All right, across the graph is going to be a straight line. That's why it's called a linear equation. To solve a linear equation, the goal is very important. The goal is the same. You isolate the variable, in this case x, and then you look for the value of x. So now let's look at 2x plus 3 equals to 7. How do we solve this? As we said, isolate the variable x. And before we can isolate the variable, we need to subtract this constant 3 from both sides. Alright, so that would be 2x plus 3 minus 3 equals to 7 minus 3. Alright, 3 minus 3 is 0, so this will be 2x plus 0, which is 2x, equals to 7 minus 3 is 4. Alright, so if you divide both sides now by 2, you should be having x to be equals to 4 divided by 2, which is 2. So this is how we solve linear equations in one variable. Alright, now we have some other examples here, and we're going to solve. We're looking at 5x minus 7 equals to 18. We've been subtracting the constant term from both sides. Now we're going to add the constant term to both sides because 7 comes with the sign minus. So to remove 7 now, we have to add 7 to both sides. So here will be 5x minus 7 plus 7 equals to 18 plus 7. Minus 7 plus 7 is 0. So that will be 5x, which is equals to 18 plus 7. 18 plus 7 is 25. If you divide both sides by 5, you should be able to get x to be equals to 25 divided by 5, which is 5. So this is how we look for linear equations in one variable. Okay, this is how we solve linear equations in one variable. Also, we'll be looking at linear inequalities. Linear inequalities. When we have the equal sign, we call this equation. As I said before, an algebraic expression doesn't have the equator sign. For instance, we have 2x plus 5 is an expression, not an equation. But when we introduce the equals sign, we make it an equation. For instance, equals to 9. However, when we have no definite, we don't make it definite, and we say 2x plus 5 is less than 9, or we say 2x plus 5 is greater than 9, or 2x plus 5 is greater or equals to 9, 2x plus 5 is less or equals to 9. We call this a linear inequality. It is still linear, but it is no longer equal because these are inequality signs. All right, these signs make it a linear inequality, so it's not an equation, it's an inequality. All right, so for instance, we have this example: 2x plus 3 is greater than 7. The same process we use in solving linear equations, the same process we use in solving linear inequalities. The only difference is that it no longer has the equation sign. So for instance, we have 2x plus 3 greater than 7. We just subtract 3 from both sides. So 2x will be plus 3 minus 3 is greater than 7 minus 3. That is 2x plus 0 greater than 4. If you divide both sides by 2, x should be greater than 4 divided by 2, which is 2. Alright? Now, we have a different problem. In inequality, when we have a negative dividing both sides or multiplying both sides, the inequality sign changes, as we see in this example. Now, when we have minus 3x less than 9, divide both sides by minus 3, it will show that we are having x divided by 9. X is less than 9 divided by minus 3. Now, 9 divided by 3 on its own is just 3. But because of this negative sign, this inequality sign changes. So we're no longer going to have it like this. It's going to be s greater than 9 divided by minus 3 minus 3. There are two other examples we can solve. We have 3x plus 4 is greater than 10. 3x plus 4 is greater than 10. Subtract the constant 4 from both sides. So 3x plus 4 minus 4 is greater than 10 minus 4. Alright, that's 3x plus 0. Not important. So we cancel that out. It's greater than 10 minus 4, which is 6. To get the value of x, divide both sides by 3, just as we do in equations. And so x will be greater than 2. That's the answer. For the last one, minus 2x plus 5 is less than or equals to 9. Now subtract the constant from both sides. Minus 2x plus 5 minus 5 is less than or equals to 9 minus 5. That will be minus 2x, 5 minus 5 here is 0, so that's gone. It's less than or equals to 9 minus 5, which is 4. We divide both sides by minus 2. Alright? Now, when you divide both sides by minus 2, the inequality sign here changes. When we have less or equal to, now it becomes greater than or equal to. So this minus 2 cancels this, and then we have x is greater than or equals to 4 divided by minus 2 is minus 2. So this is how we look for linear inequalities, or we solve linear inequalities. Please watch out for my next video where I look at graphs, linear graphing. Till meet again, do well, to stay safe, and bye bye. Also, you can contact me for your private lessons. Goodbye.